This is SpaceTime, Series 25, Episode 136. Coming up on SpaceTime, what Earth's volcanic history can tell us about Venus, the European Space Agency's Moonlight initiative, and 2 new rocky worlds discovered around an ultra-cool star. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims volcanic activity lasting hundreds of thousands of centuries and erupting massive amounts of material may have helped transform Venus from a warm, wet world like the Earth into the acidic hothouse it is today. The findings, reported in the Planetary Science Journal, suggest that by understanding the record of large igneous provinces on Earth, scientists can better understand if these events may have caused Venus's current environment to evolve. As well as being Earth's nearest planetary neighbour, Venus is considered to be Earth's sister planet. You see, they're both roughly the same size. They have a similar mass and diameter. They were formed under the same conditions in the same part of the solar system and out of the same materials. Scientists once thought Venus's dense cloud cover meant lots of rain. After all, it's closer to the Sun than the Earth, so temperatures are hotter, and that could mean more water evaporation and hence more rain clouds. So scientists envisioned that under all those thick clouds, Earth's sister planet was covered in a lush tropical green rainforest. Think of the Amazon on steroids. However, once astronomers began sending spacecraft to Venus, they quickly discovered that it's actually the closest thing to hell in our solar system. Venus has a runaway greenhouse effect, and that's produced a world where surface temperatures average a scorchingly hot 462 degrees Celsius, hot enough to melt lead. And the rain produced by the planet's thick shrouding cloud cover isn't water, but droplets of metal-eating sulfuric acid. The cloud cover is so heavy it crushes Venus's carbon dioxide-rich atmosphere like the lid of a pressure cooker, giving the planet a surface pressure some 92 times greater than the average sea level surface pressure on Earth. Scientists have seen what looks like snow caps on some of Venus's taller mountain ranges, but that snow isn't frozen water, it's actually metallic. So, on Venus, you get to be crushed, roasted, burnt and broiled all at once. Not bad for a world named after the Roman goddess of love and beauty. Venus is also very weird compared to the Earth in other ways. For example, it rotates backwards compared to most other planets in the solar system. That means the Sun rises in the west and sets in the east. And it rotates extremely slowly, a day on Venus lasting some 243 Earth days. In fact, a Venusian day is longer than a Venusian year. It takes Venus 224.7 Earth days to complete one orbit around the Sun. The surface of Venus is dominated by well over 1,600 volcanic structures. That's more than any other planet in the solar system. The study's lead author, Michael Way, from NASA's Goddard Institute for Space Studies in New York, says the large igneous provinces seen on Venus are the products of periods of large-scale volcanism lasting tens of thousands, maybe even hundreds of thousands of years. These massive fields of solidified volcanic rock cover some 80% of Venus's surface. Way estimates that volcanoes on Venus could have deposited more than 160,000 cubic kilometres of volcanic rock onto the planet's surface. That's enough molten material to bury the entire state of New South Wales or Texas almost a kilometre deep. And it's these massive volcanic outpourings which may have initiated Venus's current conditions sometime in its ancient history. In particular, the occurrence of several such mega-eruptions over a short period of geologic time, within say a million years, could have led to the runaway greenhouse effect which kicked off the planet's transition from warm and temperate to hot and dry. Way says while scientists aren't yet sure exactly how often the events which created these fields on Venus occurred, we should be able to narrow them down simply by studying Earth's own geological history. Not counting the current man-made one, life on Earth has endured at least 5 mass extinction events since the origin of multicellular life around 540 million years ago. And each of these wiped out more than 50% of all animal life across the planet. Now, according to this study and others before it, the majority of these extinction events were either caused by or accelerated by the kinds of eruptions which produce large igneous provinces like the Siberian and Deccan traps. In Earth's case, the climatic disruptions caused by these events weren't sufficient to cause a runaway greenhouse effect, as they were on Venus. But the reasons for that is something that Wei and other scientists are still working to determine. NASA's next missions to Venus, which are scheduled to launch in the late 2020s, that's the Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging, or Da Vinci mission, and the Venus Emissivity, Radioscience, INSAR, Topography and Spectroscopy, or VERITAS mission, aim to study the origin, history and present state of Venus in unprecedented detail. Wei says the primary goal of Da Vinci will be to narrow down the history of water on Venus and when it may have disappeared, providing more insight into how Venus's climate has changed over time. The Da Vinci mission will precede VERITAS, an orbiter designed to investigate the surface and interior of Venus from high above in order to better understand its volcanic and volatile history and thus Venus's path to its current state. The data from both missions will help scientists narrow down the exact record of how Venus became transitioned from warm and temperate into dry and sweltering. It may also help scientists better understand how volcanism on Earth has affected life in the past and how it may continue to do so in the future. This is SpaceTime. Still to come, the European Space Agency's Moonlight initiative and 2 new rocky worlds discovered around an ultra-cool star. All that and more coming up on SpaceTime. The European Space Agency has commenced development of the Moonlight initiative, a new project designed to ultimately provide autonomous lunar communications and navigation services. You see, while the Artemis project aims at getting humans back to the Moon and eventually onto Mars and beyond, staying and operating on the lunar surface will require more infrastructure than just habitats and rovers. To achieve a permanent and sustainable presence on the Moon, reliable autonomous lunar communications and navigation systems will need to be deployed. Think of it as a sort of lunar version of GPS. As well as Artemis, dozens of other international, public and private missions are also setting their sights on the lunar surface in coming years. And so the European Space Agency is working on the Moonlight initiative to become the first off-planet commercial telecommunications and satellite navigation provider. The initial plan will see the launch of 3 or 4 satellites into Earth orbit. They'll be transported to lunar orbit by a space tug and deployed one by one to form a constellation of lunar satellites. The exact number and specifications of these spacecraft are currently being developed, but the aim is to provide both satellite navigation and high-speed data transmission services. Right now, it's thought the constellation's orbits would be optimized to give the best coverage to the lunar South Pole, where sustained sunlight and polar ice are making it the focus of upcoming missions. These would require highly eccentric orbits. The Moonlight initiative would provide the capabilities necessary to serve planned and future missions with both a navigation service that enables accurate real-time positioning for all lunar missions and communications from the surface to the satellite and from there either to the Gateway Space Station or direct to Earth. This report from ESA TV.
Going to the Moon was the first step. Staying there is our next ambition. With dozens of international public and private missions setting their sights on the lunar surface in the coming years. But the technologies we take for granted here on Earth, satellite navigation systems like Galileo or GPS, video calls, or even fast file transfer, are very limited on the Moon. Since the Apollo program, very few lunar missions have managed to land successfully. We cannot have a sustainable lunar presence without reliable and autonomous communications and navigation. That's why ESA is working with its industrial partners on the Moonlight initiative to become the first off-planet commercial telecoms and satellite navigation provider. Launched into space, 3 or 4 satellites are carried into the Moon's orbit by a space tug and deployed one by one to form a constellation of lunar satellites. These relays connect to Earth via 3 dedicated ground stations, forging a data network that spans up to 400,000 kilometers. The constellation's orbits are optimized to give coverage to the lunar South Pole, whose sustained sunlight and polar ice make it the focus of upcoming missions. Moonlight will provide data capacities sufficient to serve these planned and future missions over the coming decades. with a navigation service that enables accurate, real-time positioning for all lunar missions. The Argonaut, or any lunar lander, could greatly benefit from the Moonlight program. With a simplified navigational subsystem, our lander saves mass, reducing cost and enabling other equipment to be carried. Its position is tracked in orbit and descent with accuracy of just a few meters, sending real-time telemetry and video footage to Earth as it touches down safely in its target area. It completes health checks and deploys its payload, whether that's supplies for the moon base or a science mission. A rover connects to the Moonlight network, either via the lander or directly to the constellation. Navigating autonomously, it saves huge operational costs, collecting lunar samples that can be brought safely back home again. The Moonlight system is designed to be scalable and adaptable. ESA is working closely with NASA on LunarNet, a new framework for lunar communication and navigation standards that ensures compatibility, so our global customer base can use the service for their own missions or deploy complementary technologies that could join and enhance the network. So perhaps before long, you could be using your roaming data allowance on the moon.
This is SpaceTime. Still to come, 2 new rocky worlds discovered around an ultra-cool star, and later in the science report, Washington warns that China's nuclear arsenal is likely to more than triple to around 1,500 nuclear warheads by 2035. All that and more still to come on SpaceTime. Astronomers have discovered 2 new super-Earth-type exoplanets, one of which is located in the host star's habitable zone, an area around a star where temperatures would allow liquid water, essential for life as we know it, to exist on the planet's surface. Most of the 5,000 or so exoplanets or planetary candidates so far discovered have been bad candidates for life. They're either scorchingly hot or freezingly cold, and the majority are gas giants. It turns out there are relatively few small terrestrial planetary discoveries, most likely because they're far more difficult to detect. The new discoveries, reported in the journal Astronomy and Astrophysics, are orbiting a small cool star known as TOI 4306, located just 100 light-years from Earth. Astronomers first detected a planet orbiting around the star last year from NASA's Planet Hunting Test Space Telescope. TESS uses the transit method to detect a slight dimming in light coming from a star caused by an orbiting planet transiting or passing directly in front of the star as seen from Earth, thereby blocking out some of the star's light. Follow-up ground-based observations by the Speculus Consortium were then undertaken in order to confirm the TESS discovery, in the process finding a second more distant planet in the same data. The inner planet in the system, designated LP890-9b, is around 30% larger than Earth and rapidly orbits its host star in just 2.7 Earth days. The second planet, designated LP890-9c, is slightly larger, around 40% more massive than the Earth, and completes its orbit in some 8.5 Earth days. One of the study's authors, Robert Wells from the University of Bern, says the second planet receives about the same amount of stellar radiation from its host star as the Earth receives from the Sun, and therefore could potentially have liquid water on its surface. But then again, when you think about it, like the Earth, Venus and the Moon are also both in the Sun's habitable zone, yet neither could support life. The Venusian atmosphere is far too thick, composed of superheated carbon dioxide, while the Moon has virtually no atmosphere at all. So, while 9c is a tantalising prospect, it's best not to get our hopes up. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.